This video will cover section 1.4 on the topic of the quadratic formula. Now, the quadratic formula can be used to solve quadratic equations, even those that will factor. And the reason we have the quadratic formula is if you took this basic quadratic equation, ax squared plus bx plus c, and you used those exact things to complete the square, where you moved c over, you took half of b, squared it, added to both sides, and did the square root property, this is what you would come up with, alright, known as the quadratic formula. And so what the quadratic formula lets us do is pull out the a, b, and c using just the numbers, the coefficients, and fill them in to get our solutions for x. Okay, so make sure that you have this formula, that you'll go ahead and learn it. You're going to need it for the test. Let's talk a little bit about the formula. So it starts with negative b, and so I'd like to say the opposite of b. So if b is positive, you'll write a negative number there, and if b is already negative, you're going to write a positive number there. So the opposite of whatever b is what should go there. Then plus or minus, because remember in quadratic there are two possibilities on the square root, and then b squared minus 4 times a times c. All of that is under the square root sign, and then all of it is divided by 2 times a. So the entire top is divided by 2 times a. Now, when you get ready to put b squared in your calculator, if b is negative, so if I have a negative b, remember if you're going to put it in your calculator to put it in parentheses when you square it, alright, to make sure that you get the correct answer. Because if you put this in your calculator when b is negative, you're going to get this as the answer. Alright, so verify if your b is negative and you're going to use the calculator, you have to put it in parentheses to square it. Okay, let's look at some examples. So I have x squared plus 2x equals 15. Now remember, before I can use the zero factor property and other properties, I want to have my equation in standard form, so that's set equal to 0. So I'm going to take my 15 and move it back on the other side of the equal sign, so when I do that it becomes negative 15. Alright, and then there's nothing remaining on the right side. I'm going to figure out what my a is, my b, and my c, and go ahead and write those at the top so I can quickly place them in my formula. So a, always the coefficient of the squared term, in this case would be 1. b, always the coefficient of the x term, or the variable that has an exponent of 1, and that is 2. And then c is the constant, which is negative 15. And then I'm going to take those numbers and place them in my formula. So we'll say x equals the opposite of b. So the opposite of 2 is negative 2, plus or minus. Then under the square root we're going to square b. So that'll be 2 squared minus 4 times a, which is 1, times c, which is negative 15. All of it divided by 2 times a, which is 1. Alright, now let's do some simplifying. So we have negative 2 plus or minus. Alright, and under the square root, you can use your calculator, alright, and just type in what's under the square root symbol, alright, and we call this the discriminant. So if you ever hear somebody refer to the discriminant, that is what is under the radical sign. Alright, so let's type that in. So we'll have 2 squared minus 4 times 1 times negative 15. Alright, and that is a 64. Alright, all over 2. Okay, now we can continue simplifying. So we have negative 2 plus or minus. Alright, now at this time I want to take the square root of 64. So to get to the square root symbol on your calculator, you can hit the second button and then the x squared button. Alright, and notice the little blue radical sign there will give you a square root. And then I just type in 64 and I hit enter. Alright, now notice whenever I type in the square root of 64, I get 8. Alright, the square root of 64 does not equal the square root of 8. Alright, when I take 64, I get 8. So look at the difference. Here's the square root of 8. That is not the same thing as 8. Alright, so notice these two things are not equal. The square root of 64 is simply the number 8. The square root of 8 is 2 point something something something. Alright, so whenever you take the square root of a number, alright, if it works out where it's a whole number, the square root sign is gone. So make sure you understand that. Alright, and then finishing up, we have 2. Alright, so now we have x can be negative 2 plus 8 divided by 2, or x can be negative 2 minus 8 divided by 2. So let's write those out. Negative 2 plus 8 over 2 is 6 over 2, which is 3. And then x can be negative 2 minus 8 over 2, which is negative 10 over 2, which equals negative 5. Alright, and of course you can always take your two answers, verify that they give you that answer in the original problem. Okay, the second example, I'm going to use my formula, so I'm going to go ahead and get A is 10, B is 1, and C is negative 2. Remember, A is always the number in front of the x squared, B is always the number in front of just the x term, and C is always the constant. Alright, so we'll do the opposite of B would be negative 1 plus or minus the square root of B squared minus 4 times A times C. And then all of that is over 2 times A. Alright, so we'll say negative 1 plus or minus. Alright, and then using my calculator, I'll just type in just what is under that radical sign. 1 squared minus 4 times 10 is negative 2. So just what's under that radical sign, I'm going to type it in just like it looks there. Alright, and I get 81. All over 2 times 10 is 20. Alright, then I want to take the square root of 81. So I put that in my calculator. Alright, notice I get 9. So negative 1 plus or minus 9. Notice I do not have a radical sign there. Alright, then I'm just going to simplify that and find out what my two answers are. So x can be negative 1 plus 9 over 20, which will be 8 over 20. Alright, which will simplify both divisible by 4 2/5. Alright, x can also be negative 1 minus 9 over 20, which will be negative 10 over 20, which will simplify to negative 1/2. Alright, I can take both of these, alright, to check my answers, and one at a time, fill them back into my original equation and verify that the left side of the equation is the same value as the right side. Alright, let's try this last example here. Here A is 1, B equals negative 3, and C equals negative 2. So now we're going to do the opposite of B. Notice B is negative, so the opposite of negative 3 would be positive 3, plus or minus. Alright, here I'm going to make sure my negative is in parentheses when I square it. Minus 4 times A times C. All of it over 2 times 1. Alright, so we'll have 3 plus or minus. Alright, and so in parentheses I'm going to put 3 squared minus 4 times 1 times negative 2, which gives me a 17 all over 2. Alright, now I'm going to take the square root of 17. Alright, but notice that the square root of 17 is a decimal. I don't want any decimals. If I look at the factors of 17, there are none of them that are perfect squares, so I can't simplify 17 any further. So since I can't put 3 and the square root of 17 together because they're not both square roots, then this is as simple as I can get my answer, and I'll leave it there. Now if you need to practice on simplifying square roots, say for example you had the square root of 48. Alright, if I take the square root of 48, alright, notice I get a decimal, but there is a factor of, or actually a couple of factors of 48 that I can take the square root of. I always want to pick the largest one. The largest one would be 16, and so 16 times 3 is the same thing as 48. And so you can see what I'm doing here. The square root of 16 times the square root of 3 is the exact same thing as this. The square root of 16 is 4. I can't take the square root of 3. So the square root of 48 will simplify to 4 square roots of 3. Now if you're not sure about what I'm doing here, then you might want to go by the Learning Lab and get some practice on simplifying radicals. There will most likely be some problems when you get here that this radical will be able to be simplified, and you'll want to take it to its simplest form.